refresher. Okay, so number one, it's asking how much 0.2 molarity H3PO4 is needed to react with 100 milliliters of 0.1 molarity NaOH. And we have the balanced equation right here. Now, whenever we use talk about molarity, we are going to use the molarity formula, which is moles over liters. Okay, and so it's asking us how much 0.2 molarity solution is needed to react with the base. Okay, so let's just put the information that we have here just so it can be organized. And same as usual, if at any point you feel like, hey, I know how to do this, you can kind of zone me out for a second and then finish it up and just check your answer at the end, okay? So for the H3PO4, we know that it's 0.2 molarity. For the NaOH, we know that it's 0.1 molarity and that we have 100 milliliters of it. Okay. All right, so now this question is asking how much we need. So if it's asking how much, that means we're going to be probably looking for either grams or volume. But in this case, since we're talking about molarity, we're probably going to be talking about volume, right? So here we're going to be talking about volume, and we measure volume in terms of liters and milliliters. Okay. So that's what we are going to be looking for at the very end. Any questions so far? Okay. So we know that we start with this, and in order to use a balanced chemical equation, we need to turn everything into moles, okay? Because a balanced chemical equation gives us information, but all the numbers are based on moles. And so since we have 0.1 molarity NaOH, and we have the volume, what we can do is we can use the molarity formula to find moles, because molarity is moles over liters. And so I can actually rearrange this equation to moles equals molarity times liters. Okay. So I just rearranged it by multiplying by liters on both sides. That'll let me find moles. Any questions so far? Does it make sense so far? How to set this up? All right. So what we're going to do now is we're going to just plug in our numbers. Now we want to find moles of NaOH. So I'm going to be looking for moles of NaOH. So I'm actually going to let you guys plug in the numbers and try solving it out first. So take about a minute to do that. We're going to be finding moles of NaOH. And if you think you can go all the way and then convert it into the volume of H3PO4, you can feel free to do that as well. But I'll give you guys a minute, just a minute for moles at least, and then we'll move on together. But if you feel confident, feel free to just go ahead and try it on your own. Maybe another 20 seconds to finish up. All right, again, if you're finishing up, feel free to finish up and check your answer at the end, but I'm gonna start going over it. So let's plug in the numbers. So for molarity, what's the molarity of NaOH that we're working with? Yeah, 0.1 is written right there, so we have 0.1. And then for the volume, can I plug in 100? No, because it's in milliliters. So I'm gonna have to convert it into liters, which is gonna be 0.1 liters. Okay, just divide by that 1,000 or move the decimal 3 times to the left. So you'll have 0.1 liters. Okay, that's gonna give us a value of 0.01 moles of NaOH. Everybody got that? All righty. Okay, so what we're gonna do is now we're gonna use the balance equation to convert that into moles of H3PO4 because we are looking for the volume of H3PO4, and so we need to use we need to turn it into H3PO4 using the equation. So what we're gonna do now is we're gonna take the value that we have, 0.01 moles of NaOH. Okay, and then we're gonna use the balanced equation. We're gonna put 3 moles of NaOH because that is the ratio between 1 mole of H3PO4. Okay, all right, that is going to give us the moles of H3PO4. So I can just go to my calculator real quick. And then I'm just going to plug that in. So 0.01 divided by 3, and then 0.00, and then 3 repeating. So I'm just going to round it off to 0.0333 okay, moles of H3PO4. All right, and then last but not least, we need to use the molarity formula to finish it up. So we're just going to take the molarity formula, and we have moles over liters. But I'm not looking for moles or molarity, so I'm going to just rearrange the equation. If I want to just find liters, I can rearrange this equation to moles over molarity, right? Because if I multiply by liters on both sides, I can get liters on the top, and then I could divide by molarity, and that'll bring molarity to the bottom. And that'll give me liters equals moles over molarity. All right, and then from there, just simple, we just plug in our values. So we're gonna take the moles of H3PO4, which is 0.003333, and we're gonna divide it by the molarity, which is 0.2. So we'll get a final volume of 0.016, I'm gonna round it to 7 liters. Okay, so that is how much of the H3PO4 solution you will need to neutralize the NaOH. Okay, so I think the most difficult thing that I'm noticing on the exams is that you guys all know how to do Stoich. You guys know how to do the conversions, but it's kind of putting it all together and figuring out like the process that you need to follow in order to solve these problems. And honestly, that's the hard part about AP Chem. Like, it's not about knowing the individual skills. It's about being creative with figuring out the solutions. There's a lot of different ways you can solve this. And so I just want to encourage you guys, make sure you guys are doing practice problems. Make sure you look for them actively outside the class. There's a lot of good stuff on YouTube and Google and whatnot, because that's kind of how you just get better at AP Chem. I can't, unfortunately, give you all the types of problems you'll see. And so you'll have to find as many as you can just so that you can kind of get exposed to them. Like I said, this class is a little bit unfair in the way that I can't show you what's going to be on the test. All I can do is kind of show you how to do certain skills that you will need to solve those problems, but I can't give you all of the scenarios, okay? All right, any questions about this problem or just in general? I feel like I'm depressing you guys after every single test. Just get sadder and sadder and sadder. I don't know. You guys are good students, so it's kind of weird seeing a bad grade, but yeah, AP Chem is tough. It's a tough class. I don't know if this is rewarding at all, but yeah, it definitely is challenging. All right, let's move on to the next question. Dude, do you know how depressed I get while I'm grading your test? My hand starts hurting because of all the crossing out I gotta do. But I'm sure it's harder for you guys, but just know I feel your pain. My right hand, as I cross out your answers, starts getting sore. Okay, it's like a tricep workout. Okay. Let's do one more problem, and then after that, I'm going to give you guys the rest of the class period to either check your test with me. I can go over some of the test questions, probably the FRQ, and if you want, you guys can work on homework 5B, or if you haven't turned in 5A yet, you can do that. Okay, so this is a solution Stoich problem, but if you guys notice, there's some stuff with gases on there too, so it's kind of like a mixture. Like I said, we're gonna be synthesizing these skills together. So I'm gonna actually give you guys about 5 minutes, and I want you guys to try solving this out on your own. Okay, if you really need to, you can work with someone next to you if you get stuck at any point, but really try to solve this because this is actually a pretty simple Stoich problem, so it shouldn't be that difficult. And so this is a good way to see, hey, like, am I caught up with my Stoich skills? Like, this should be time consuming, but you guys should be able to figure this out, okay? So I'll give you guys about 5 minutes. Again, you can work with the person next to you, but I encourage you to try it on your own. But if you really do get stuck, it's better to just talk it out with someone than to just sit there looking at the paper. So give you guys about 5 minutes, and then we'll go over it together. Let me know if you guys have any questions as well. Okay, so let's start going over this problem. Again, same thing as usual. You want to use the information that you have in the text and just kind of write it down on the side. That way you have somewhere to look at it real nice and clean. So it says we have 25 milliliters of a 4 molarity solution of HCl. So HCl, 25 milliliters, 4 molarity. And then it's asking how many grams of zinc does it react with? So at the very end, you want to find grams of zinc. This is what you're going to be looking for. It's also asking you what's the volume of H2 gas produced at STP. So you're also looking for liters of H2. Okay, so you're looking for 2 different things in this problem. Now, we talked about this last time, but if you ever see the word or the term STP, what conversion can you automatically just write down? Yeah, 22.4 liters equals 1 mole, because if you have a gas at STP, it will always be 22.4 liters. I believe this is on the handout that I gave you guys last time, but if not, just memorize it, 224, okay? It'll make your life a lot easier. Okay, so let's start with the zinc because that's the first one it asks. And from here, it's just the same thing that we've been doing. You're gonna take the molarity formula, and then we can rearrange it to look for moles. And so it'll be moles is equal to molarity times liters, okay? You don't have to rearrange it if you don't want to. I just like to do it because it kind of looks prettier, and it's my way of flexing that I know how to do basic algebra. But we're going to plug in molarity, which is going to be 4 molarity. Okay, and we're talking about HCl here. And then we're going to plug in 0.025 liters because it's 25 milliliters. So we just move the decimal 3 times to the right. That gives us 0.025 liters. All right, next we're going to go on our calculator and just plug that in. So we're going to do 4 times 0.0025, and that'll give, oh wait, I did 0, my bad. 4 times 0.025, and that's going to give us 0.1. So that means we have 0.1 moles of HCl. All right. Next, we're going to take that value of 0.1 moles of HCl, and then we're going to use the chemical equation. The ratio here is 2 moles of HCl per every 1 mole of zinc. And then from here, we can actually just add another conversion factor to find the grams of zinc. We're going to do 1 mole of zinc, and then the molar mass of zinc is 65.39. So I'm going to plug in 65.39 grams of zinc. And then there you go. We can see that our units will cancel out the way that we want them to. We'll be left with grams of zinc. So all we need to do is divide by 2 times 65.39. That'll give us 3.2, I'll round that up to 7. Okay, so 3.27 grams of zinc. All right, any questions? Hopefully that wasn't too bad. Like I said, this should be, it's kind of a basic Stoich problem. We will be seeing harder ones later on as the year goes on, but hopefully you're able to get this on your own. This is part 1 of this problem. Okay, the second part, we're going to be looking for the liters of H2. Now, we don't need to do all of this conversion again. We can actually just start with the moles, okay? So we got 0.1 moles of HCl. Now we're looking for liters of H2. So we can just set up a pretty simple fraction. We can see that it's 2 moles of HCl per every 1 mole of H2, right? We get the numbers from the balance equation, 2 and then 1. All right, and then from there, we can just use our conversion factor right here. Since H2 gas is at STP, we're gonna turn it into 1 mole of H2 gas is equal to 22.4 liters because it's at STP. And so we just plug it into the calculator. So we got 0.1 divided by 2 times 22.4. And that means we will produce 1.12 liters of H2 gas. Okay. All righty. So that is that problem. We got some solution stoichiometry in there. We got some gas stoichiometry in there. If you were able to get that on your own, great work. You are actually in a pretty good shape for the exam in terms of the stoichiometry. All right, any questions on this problem, guys? Yeah, what's up, great? Yeah, so STP is, yeah, that's the description you gave me is correct. It's when the gas is at 1 atm and 273 Kelvin. So we can automatically assume that. But I mentioned last time that when a gas is at 1 STP and 273 Kelvin, we can automatically assume that it's at 22.4 liters. Every mole is 22.4 liters. And if you use the ideal gas law to calculate it, you can actually calculate that out. Yeah, but when you see STP, and you know you have to do Stoich, just automatically assume that it's 22.4 liters per mole. It'll save you a lot of time and it'll help you get the right answer. Okay. Any other questions? That was a good one. Okay, I'm gonna leave this up here so you guys have it as a reference while you guys do your assignment. I'm gonna delete it for just a second because I do wanna, I guess, give you guys a hint about what's gonna be on your exam. Okay. So while you guys are working on your homework and whatnot, I do want to mention that in terms of gases on your exam, make sure that as you're prepping that you know how to do 5.15 and 5.16 on the class workbook. I think there's problems like this on your homework as well. Make sure you know how to do these on your own because these are the 2 most common gas law types of problems that will be on the AP test. Also, will probably see it on your exam. So know how to do these 2 specifically. Obviously, you need to know how to do all the gas law stuff we covered on the stuff in the text, but I do want to highlight these 2 because these 2 are very prevalent, and it's a good way that the AP exam people, they like to test whether or not you know gas laws. Okay, so 5.15, 5.16 in the workbook. Make sure you guys know how to do that. There is a recording of it posted on Canvas for you guys in our video lectures, so you guys can check that out. But if you have any questions, you guys can ask me. Okay. Alrighty. So that